Hey guys, today we're going to be continuing our look at the normal distribution. We're going to be moving on to section 6.2. Still talking about the normal distribution, which we will for a while. And today we're going to be doing a very similar thing to what we did in the last one, where we took the normal curve and we said something like the mean of this normal curve is 70 and the standard deviation is 6. And so we would draw out the normal curve. We would put 70, the mean in the middle, if you remember, right? Then we would go out 1 standard deviation, it'd be 76. We go out 2 standard deviations, that would be 82. And then we go out 3 standard deviations, that'd be 88. And then we go the same in the opposite direction. We'd subtract 1 standard deviation, we would get 64. We'd subtract 2 standard deviations, get 58. Subtract 3 standard deviations, we get 52. And then we had all of these different values using what we call the empirical rule. So we said, like, for instance, like 34% of the data was between 70 and 76, right? We knew that 34% was in that section, right? So we had all of this, like 68% of the data was within 1 standard deviation, 95% was within 2 standard deviations, and then 99.7% was within 3 standard deviations. So we had all these facts. And so all the questions were something like, what percent is, let's say less than 64. So then what we would do is we'd take the area of this section, take the area of this section, take the area of this section, and we would add those together, and that would tell us how much is less than 64. Okay, now today, the thing that we're going to change about this is, what if the question was instead, what percent is less than, let's say, 63? So the difference here is 64 was a nice number that happened to be one of the standard deviations, right? So when we're subtracting the standard deviation, we ended up with 64. So it was easy to calculate that. But 63 is going to be right here, right? So it's not one of those nice, easy -1 standard deviations. It's a different value. And often we're not always just going to want to know what percentage at whatever happens to occur as a multiple of the standard deviation. Sometimes we need to know different values. So we don't have a nice, easy rule that says, well, approximately this percentage is in this section, because it's going to change. It changes as we change our numbers. And it would be the same as if it was 62. We wouldn't know how much was in this section. So that's going to be the difference today. We're not necessarily going to have a nice, easy multiple of the standard deviation when we're calculating these. But we're still accomplishing the same thing. We're looking at the normal distribution. We're calculating an area under this normal distribution, and that's going to tell us our percentage of a given value. So let's flip over to the problems we're going to be doing, which is on Delta Math. A similar setup, like I said, to what we saw in the last one. The only difference is, again, this might not necessarily be a multiple of the standard deviation. All right, so this problem says when Jace goes bowling, his scores are normally distributed. So we're going to be using the normal curve. Mean of 195, so mu equals 195. Standard deviation is 14, so sigma equals 14. What percentage of the games are between 177 and 195? So if I were to go ahead and sketch out my normal curve, I would have 195 in the middle, right, because that's my mean. I would add 1 standard deviation, that would give me 209. Add another one, that would give us 223. Add one more, that gives me 237. And if I were being subtracting here, that would give me 181. Subtract 14 again, that gives me 167. Subtract 14 again, that gives me 153. And notice we're asked 177 to 195. So 177 is going to fall on here, and 225 is going to fall over here. So neither of those are multiples of the standard deviation. So when we're calculating the percentage, what we're basically doing is finding the area under this normal curve in between these two boundaries. So it is important that you can visualize what you're actually doing here, or finding the area between those two values on the normal curve. But again, this presents a problem because we don't have that nice empirical rule that says, well, if it happened to be 181 and 223, that would have ended up being a lot easier for us because then we could just add the sections together. However, that's not the case. So we're going to do the calculator method today, and then eventually we're going to learn something called a z-score, but I'm going to show you how to do it on a calculator today. It's going to be very similar to when we did the Poisson, like PDF and CDF. And it actually has a statistics calculator on here as well that you're welcome to use. It's very similar to your TI-84 calculator. So let's go ahead and I'll just show you the statistics calculator version first. There's 4 things that we need. We need a mean, which we've got. We need a standard deviation. We're going to need a lower bound, and we're going to need an upper bound. And those are pretty self-explanatory for this one, right? Because our lower bound is the smaller number, 177, and our upper bound is 225. So those aren't going to be too difficult to find, especially in this case. Very easy to see our lower bound and our upper bound are those 2 values, and we've got our mean and our standard deviation. So what we're going to do on this calculator on Delta Math is you're just going to click on Statistics Calculator, and it'll pop up in a new tab. And then what you're going to do is on this main menu, you're going to click the drop-down box and go down to Distribution, because we are talking about a distribution here, normal distribution. And then we're going to click on the sub-menu, and we're going to be doing normal CDF, normal CDF. Remember, the C stands for cumulative, so we're adding up a bunch of different sort of probabilities in between those 2 values. And you'll see we're asked for a lower, we're asked for an upper, we're asked for a mean and a standard deviation, and we've got all those. Our lower is 177, our upper is 225, our mean is 195, and our standard deviation is 14. So all we do is type those in, calculate, and there we get our result, 0.8846, whatever. All right, so what this is saying is there is basically, let me go ahead and flip the other one. So 0.8846. This is essentially saying there's an 88.5% chance of bowling between 177 and 225. We're supposed to put this in as the nearest tenth. Okay, so it does say percentage. Actually, maybe should have done this before. It does say percentage. So I'm guessing it wants 88.5 because we have to convert that to a percent. From a decimal right there is a decimal. Convert it into a percent. We move it over 2 places. And then rounding to the nearest tenth. Sorry, move this here. 88.46 would be 88.5, I believe. That's how it wants it. All right, very good. Let's go ahead and look at another one. Let's clear our screen here. Okay, so this one is talking about systolic blood pressure is normally distributed. So if we were to draw our curve here, normally distributed with a mean of 135, standard deviation of 6. So we'd have 141, 147, 153. And this way we would have 129, 123, and 117. And it asks what percentage of the males in town have a systolic blood pressure higher than 137. So 137 occurs right here. Again, not one of these nice values. And we're talking about higher than. So we want to know values greater than 137. So this area under the curve right here. So for this particular one, we've got a mean of 135, right? A standard deviation of 6. And then we do need a lower and an upper. All right, now it says greater than or higher than 137. So that means the lowest amount we want to include is 137. For the upper bound, this technically goes all the way to infinity. So what we're going to do is just type a bunch of 9s. Just type like 5/9 should be fine. Basically just a really, really big number, and that is fine. It works for infinity. That's how we can type it into our calculator. So if we're asked for a greater than or higher than, our upper is going to be 99999. If we're asked for a less than or a lower, then our lower bound is going to be negative 9999. Let's talk about that. All right, so let's go ahead and type this into our calculator on here. So we're going to do, actually, we already have it open from the previous one, but I'll show you again how to get there. We'll click on the drop down, go to distribution. Submenu is normal CDF. Our lower, flip back, was 137. Our upper, again, we're just going to type a bunch of 9s. Should be plenty. Our mean is 135, and our standard deviation is 6. So 0.3694. We want to move it over 2 places. 36.94, which if we're rounding to the nearest tenth here, we look next door, it's lower than 5, so it'll be 36.9. 36.9%. All right. I also did want to show you how to do this on your TI-84 calculator. It's very similar. So we'll do that for this next one. Sometimes it's easier just to do it all on your TI-84, and it's good to know how to do it on that one as well. This next one, we're normally distributed, a mean of 1,600 hours. Draw our normal curve here. So our mean is 1,600. Standard deviation is 55. What percent lasts between 1460 and 1640? So I'm actually not going to write all the values on here. I think you kind of got the idea, but 1460 is going to be somewhere over here. And 1640, maybe right here. So we're asked to find how much is between those two. So we're finding that area under the normal curve. Okay, so we've got a mean of 1,600. We've got a standard deviation of 55. We've got a lower of 1460 and an upper of 1640. So pretty self-explanatory on how to type this in on your Delta Math calculator. On your TI-84, I wanted to go through the directions on that as well. So let me erase this. You can write out your directions here. All right, so this will be our TI-84 directions. First thing you're going to do is hit second and then vars, which is distribution. So second vars, that's your distribution one, DISTR. After you've done that, turn your calculator on first. All right, you'll see it's actually the second thing there is normal CDF. Click on normal CDF. Very simple. And then it's just going to, again, ask you for your lower, upper, mean, and standard deviation. So just type in your lower, upper, mu, and sigma. That's all there is to it. And then you're just going to hit paste and enter. Paste, enter. All right, that's it. So for this one, if we're going to go ahead and do that, our lower bound is going to be 1460. Our upper bound is 1640. Our mean is 1600 and our standard deviation of 55. We hit paste and then enter, and we get 0.7610. So that will be 76.1%. So we'd say 76.1% of light bulbs should last between 1460 hours, or 1,460 hours, and 1,640 hours. 76. All right, let's go ahead and look at the next section. The next section is going to be very similar, except we're also going to be given a population. So it's just going to be one extra step. All right, so this one we've got IQ scores, normally distributed. mean of 100. Standard deviation is 15. So if we were to add this, it's going to be 115, 130, 145. You do not have to draw this on everyone, but I do want you to get the flavor of what we're actually doing here. 85, 70, 55. It says if you were to randomly select 1,200 people, how many of them would have an IQ between 71 and 118? So 71 would be here, 118 somewhere over here. What percentage or how many people, if you were to just take a random sample of 1,200 people, how many would you expect to have an IQ between 71 and 118? I'm guessing that's a lot because that would include a huge part of our population. Most people would fall within that range. So we're going to approach this the same exact way, just ignoring this for right now. We'll come back to that 1,200 people in just a minute. So we're going to start solving it the same way. Use our mean of 100, our standard deviation of 15, our lower and our upper. Lower is 71, upper 118. And either choose to do it on your TI-84 calculator. So second vars, normal CDF. We'll do our lower of 71, upper of 118, mean of 100, and standard deviation of 15. Paste it all in, and we get 0.8583, bunch of different stuff. The advantage of then doing this actually on your TI-84 calculator is you got all these decimals in there. The next thing we're actually going to do to determine the number of people, so this is our probability, right? What percentage we would expect. Now, if we have 1,200 people, all we're going to do is take that and we're going to do 1,200 times this probability, 0.85833. So the advantage of using your TI-84 calculator is you've already got that big decimal loaded in there, and all you do is just hit the times button and then just do 1,200, and it'll just take that previous answer and just hit times 1,200, and then you'll get 1029.99. We're supposed to round this to the nearest whole number because we're talking about people. So this would be 1030, so 1,030 people we would expect. 1,030 out of 1,200, we would expect to have an IQ between 71 and 118. So again, the only thing that we're adding is that we're taking that probability, we're then multiplying it by the population or the sample size. Okay, so only change is multiply probability by population or sample. It's the only thing that's changed in this section. We could do it the same way with the stats calculator. Again, navigating there, you go distribution, you then go normal CDF. We do our upper and our lower. So your upper and lower was 71 and 118. Mean was 100 and standard deviation was 15. Calculate. We're going to get the same results. And then we just take this and then we times it by 1,200 because I had 1,200 to get 1029.99 equals 1030 people. So whatever you prefer for that, you got options. Let's look at just maybe two more here real quick. I wanted to show you one where it was less than